This is a short video just to look at the essential skills you'll need to get started in the Analytic Geometry unit of MPM2D. First thing that would be useful to know is how to find the midpoint of a line that connects 2 points. So let's plot these points 1, 4 here, and the point 5, minus 3. And what we need to do is mathematically find the exact midpoint of this line, if you will, that connects A to B. Well, you can just use counting and logic here if you like, because you know that to get from 1 to 5, you're going across 4, right? So therefore, if we just go 2 across, we'll be halfway across at least. And to get from 4 to minus 3, you drop down 7. So if we drop down half of that, 3.5, we should be able to find the halfway point. So it's 2 across from the 1, 4, and then down 3.5, which will put us here at 3.5. That all makes sense visually and graphically as well, which is important. Let's just calculate that formally as well. So just to get used to this notation where these points will be labeled x1, y1, x2, y2. Notice that the point on the left is x1, y1. So the midpoint formula is just the average of the x values and the average of the y values. And that's really just saying go halfway between those 2 points, right? Which is what we did here. So the average of 1 and 5, the x values. Then we got the average of the y values, 4 minus 3. And you can see we arrive at 3.5 as we did on the graph. Let's look at perpendicular slopes. So same points. Very important skill this is to know how to calculate not necessarily the slope of this line, although you'll need that, but what they're asking for here is the slope of a line that is 90 degrees to line AB, perpendicular. You don't have to use the midpoint. We'll do that later when we do perpendicular bisectors. What we're looking at here is just how do I calculate slope AB, which I'll call the slope 1, and then how do I use that to calculate the slope of this 90 degree line perpendicular M2. Well, one way to think about slopes is rise over run. We already said, didn't we, that we dropped down 7 and went across 4 here. So one way to think of that is rise of -7, so not really a rise but a drop in this case, and across 4. If you want to calculate that formally using again the notation, then you can use y2 minus y1 over x2 minus x1, and you'll arrive at the same result. You'll see here you'll get -3 take away 4. So that's where your minus 7 comes from, -7, and here you've got your minus 3, sorry, your 5 minus your 1, I beg your pardon. So your x values on the bottom, 5 minus 1, and you'll see that's where the 4 comes out. Well, the slope M2 is actually just the negative reciprocal of slope M1. So what that means is if you just take this fraction and turn it upside down and reverse the sign, you will actually have the slope of the line that is 90 degrees to line AB. You can verify that mathematically here, because you can say 1 divided by -7/4 is the same as 1 minus 1 times 4 divided by -7, and you can see there what you'll get is 4/7. So here this slope -7/4 is perpendicular to this slope +4/7. Length of a line that connects 2 points. This is actually just Pythagoras. So you guys know Pythagoras from earlier, right? A squared plus b squared equals c squared. We're going to use the same kind of idea here. So my 1, 4 and my 5, 3. Let's always visualize the triangle in try and graphically check your calculations in your algebra and vice versa. So here, as we said before, this was 7 or minus 7 as you dropped from here to here, and 4 as you moved from here to here. So you can think of this as a Pythagoras problem where you're trying to figure out the hypotenuse, if you like, and the hypotenuse is the length of the line AB. So 4 squared plus 7 squared in this case, 16 plus 49. If I take the square root of that, I'm taking the square root of 65. If you want a more formal analytic geometry formula for this, it's basically just about calculating the minus 7 and the 4, right? So just doing what we did before with subtracting one value from the other. So remember, this is x1, y1, that's the point on the left, x2, y2. So the formula is just basically like figure out the difference in the y values and then figure out the difference in the x values, which we did here, and we found we had minus 3 take away 4 squared. You can see that's where the 7 comes from. Minus 7 squared is just the same answer as positive 7 squared. And here we've got x2 minus x1, so there's the 5 minus the 1 squared. And you can see that's where I got the 4 from here. So that will also confirm, using that technique, that your length of the line that connects these 2 points is root 65. Sorry, that's point A there. And this is point B. Last thing, equations of circles are pretty simple in grade 10 because you're always looking at circles that are centered on the origin, which means they are always given in this format where whatever this number is here will tell you the radius of the circle. So it's always centered on 0, 0, and in this particular case, for instance, 5 is the radius. So I can draw a circle or visualize a circle like that. Oops. Now I've been asked, prove that this point is outside that circle. So, I mean, I'm pretty sure it is from just looking at the drawing, but it's kind of close, isn't it? 4, 4. So how can we be sure? We can prove it mathematically because we can take 4, 4 and plug them in as x and y here. So 4 squared plus 4 squared, so that's x squared plus y squared. What does that equal? That's 16 plus 16 is 32. 32 is bigger than 5 squared. So what you've proved here is that this point is outside the circle. Just like if you were to take a point like, let's say 3, 3. Let's try 3, 3. If we do 3, 3, 3 squared plus 3 squared, that's 9 plus 9 is 18. Well, we see here 18 is less than 25, is, if you like, numerical proof as well as graphical proof that the point 3, 3 is definitely inside the circle. We could extend this to a point on the edge of the circle, actually. So let's take this point here, minus 3, 4. We suspect this is right on the circumference. And we can prove that by saying, if I do minus 3 squared plus 4 squared, it should equal exactly 5 squared, 25. And it does, doesn't it? 16 plus 9 is 25, so is exactly 5 squared. You have proved that that point is right on the circumference of the circle.